Hi friends, today we are going to see the topic how X-rays are being formed. So let's see the key characteristics of it. X-rays are the type of electromagnetic radiations and high energy. So we know about the visible light, that visible light is having a certain wavelength and certain energy. The X-rays are having short wavelength and hence they are having the high energy, which is not visible to our naked eyes. Again, they are produced with high energy electron collide with the target material. So how they are being produced, these X-rays, when we are very high energy electrons are colliding in a target material, then in that particular process, in that particular collision, there is some two types of main mechanism which occurs and because of which the X-rays are being made. So let's see the experimental setup, that how it has been forming. You can see over here that there is a cathode and anode over here. This is a Coulomb X-ray tube from cathode. So as we increase the current over here of the cathode, the filament will get more and more heated, and because of that the electrons will emit from it. More the filament gets heated, more electrons are going to come out of it. Okay, so more current, more electrons are going to get out of this filament. Then with the help of step-up transformer, we can increase the potential difference between cathode and anode. As we know, anode is positively charged and cathode is negatively charged. If we increase the potential difference between this, the electrons which are emitting from the filament will accelerate with a very high speed. And at anode, we have kept the target over here. So when the high electron beam with lots of acceleration will come and hit on the target, there will be the collision of electron with the target atom, and in that particular collision, the type of collision it is going to occur, there is a formation of X-rays over here. Okay, so here we can see the cooling fins are there, which is maintaining the temperature inside this cooling tube. Okay, and others I have already explained you about the functioning of step-up transformer and step-down transformer. Okay, so now let's see that how these two types of X-rays are forming over here. So let's come to the our presentation. Here, depending on the collision of electrons with a target material, two types of mechanism occur. First is Bremsstrahlung radiation. Now in this particular radiation, what is happening is when the high energy electron passes near the nucleus of an atom, it is deflected by the strong electrostatic force. And this deflection causes the electron to deaccelerate. So it loses its energy, it loses its kinetic energy, and there is an emission of the X-ray photon. So let's see this with a diagram. So if this is your fast moving electron which is coming from your cathode, that electron beam which we have seen in the previous slide, then over here you can see that this is your target atom. So target material we have seen over here, right? So these are the electrons, fast moving accelerating electrons are coming, and here is your target, and here target atom, here one target atom we are considering. So if the fast moving electron is coming and it is passing near this nucleus, so if it is passing very close to the nucleus, then it is going to lose most of its kinetic energy which it is having, and that energy, loss of energy, we know by law of conservation of energy that energy can neither be created or destroyed. So whatever kinetic energy the electron is losing because of the nucleus, because of the deacceleration of the electron, that energy is getting in the form of photon, and that's what we called it, the X-rays are being emitted or photons are being emitted because of the deacceleration of electron as it is passing near the nucleus. Now why we called it continuous X-rays? Because depending on that electron, whether the electron is passing very close to the nucleus or it is passing at certain distance from the nucleus. So it is very obvious that if the electron is passing very close to nucleus, the more attraction force will be there and it will get deaccelerated, means it will lose most of its kinetic energy. But if the electron is passing much away from the nucleus, then it is not going to lose all of its kinetic energy, but it will lose some of its kinetic energy, and there will be the certain wavelength which is going to certain energy of photon which is going to emit out of it. So we are going to get variations of X-rays or variations of photons which are going to emit because of the deacceleration of electron, depending on at what particular instant it is getting deaccelerated. Okay, so in this way we are going to get the continuous X-rays. Okay, now what are the characteristics of this continuous spectrum? So continuous spectrum of wavelength we get out of it. then intensity increases with the energy of the incident electron. So if more electrons are coming with a very high intensity, then the energy of the X-ray will be high. Maximum wavelength is inversely proportional to the energy of the incident electron. So more the energy of the incident electron, the shorter is going to be the wavelength of it. Okay. So these are some of the characteristics of the X-rays. Now let's see how the characteristics X-rays are being formed. So now in this particular thing, what is actually happening is, so let's understood this with this diagram. Here you can see that incident electron is coming. This incident electron when strikes and interact with the electrons of the target atom. Okay, so whatever the target atom is over here, if that incident electron is interacting with the first orbit or the K shell of the electron, what the incident electron is doing, it is replacing this electron of the K shell, and that electron gets ejected. Also this incident electron gets scattered over here, and there is a vacancy which is being created in the K shell. So this electron which was already present get ejected from the shell, and the incident electron gets scattered in the another direction, because of which there is vacancy which is created in the K shell. As we know that this vacancy will not exist over there for the longer period of time. So the next shell electron which is present, it is K shell, this electron will try to fill that vacancy. So this electron will jump from its L shell and it go on the K shell. As we know that the K shell having the lowest energy, and as we go from K to L and M shell, the energy of the shell increases. So if L shell electron is fulfilling the vacancy of the K shell, so it is going to require less energy to fulfill this particular shell. So this L shell electron is going to lose the energy, and that energy which it is going to lose in order to fulfill this K shell is called as characteristics X-ray photon. So it is going to release certain amount of energy depending on this shell energy, and that's why we call it as a characteristic X-ray photon. So again, let's see this. When a high energy electron knocks an inner shell electron out of a target atom. Okay, so whatever the electron is coming, that is knocking off that inner shell electron of the target atom, because of which there is a vacancy is being created. And when that vacancy is created in the inner shell, the outer shell electron can then do the transition to fill this vacancy, and in that particular process there is a release of energy in the form of X-ray photon. Okay, now what is the characteristics of this type of X-rays? They are the discrete spectrum of wavelength and specific to the target material. So whatever the target material is been there, depending on the target material, the specific wavelength of energy is going to release. Okay, so wavelength depends on the energy levels which is involved in the transition. So whatever if the K shell inner shell electron has been replaced, so depending on that whether the L shell electron is going to fulfill that vacancy, or M shell, third shell electron is going to fulfill that vacancy, depending on which energy level is involved in that transition, the wavelength is going to release. So that amount of energy is going to release from that atom, and that's why we call it characteristic X-rays. Intensity increases with the atomic number of the target material. Okay, so whatever, if the higher the atomic number of the target material, then the intensity of the X-ray is going to be high. What are the general key characteristics of X-rays? Short wavelength. This gives them high penetrating power, allowing them to pass through many material. As they are having the short wavelength, they are having the high penetrating power. They have the high energy which makes them capable of ionizing the atom. So they can ionize any kind of atom, and this is very useful in medical imaging and radiation therapy. So this is one of the applications of it which is having because of high energy. They are having no mass or charge. So X-rays are the electromagnetic waves and do not carry any mass, or they don't have any charge in it. Travels in a straight line. So X-rays travel in a straight line, which is important for medical imaging applications. Can be absorbed or scattered. So X-rays can be absorbed by the matter, especially the dense material like bones. They can also be scattered, which may affect the image quality. Okay. so they can be absorbed and scattered. Then there are few applications of X-rays. It has been used in medical imaging, it has been used in industrial radiography, scientific research and radiation therapy. So you can see these are some of the applications. You can go through it and read it. Okay, so thank you for listening.